On a road course in 1969, Ford had a problem. Not a horsepower problem, not a money problem. Because sitting inside Ford's performance department was an engine so large, so radically engineered, and so closely related to Ford's NASCAR ambitions that it couldn't even qualify for the war Ford was fighting on the Trans Am circuit. The engine displaced 429 cubic inches. Trans Am wanted roughly 305. That wasn't a small difference, that was a different universe. And here's the strange part. Ford already had a Mustang designed specifically to fight Chevrolet, Dodge, Plymouth, and AMC and Trans Am. But the biggest engine in Ford's new Boss family wasn't that car's weapon. It couldn't be. The rules wouldn't let it. Most people remember the Boss 429 as one of the most outrageous Mustangs Ford ever built. A giant V8 squeezed into a body that was never designed to hold it. Massive aluminum heads, a semi-hemispherical combustion chamber, a 4.36-inch bore, a short 3.59-inch stroke. But what most people don't realize is that this engine was born from a completely different battlefield, NASCAR. And its story begins with Ford getting tired of losing. By the late 1960s, stock car racing had become an engineering arms race. Chevrolet had its big block weapons. Chrysler had the 426 Hemi. Ford had already experimented with the legendary 427 SOHC engine, but NASCAR rejected that direction, forcing Ford to rethink its answer. The competition was fierce. The stakes were enormous. Winning NASCAR meant more than trophies. It meant Monday morning sales. It meant bragging rights in showrooms across America. It meant proving that your engineering was superior to Detroit's other titans. So Ford engineers went back to the drawing board. They created something enormous. The result was a 429 cubic inch V8 built around a completely different philosophy from the small block engines dominating road racing. And the numbers were intimidating. The bore measured 4.36 inches. The stroke was only 3.59 inches. That combination mattered. Instead of using an extremely long stroke to make torque, Ford gave the engine a huge bore and relatively short stroke. That created room for enormous valves and allowed the engine to breathe at high RPM. The heads were aluminum. The combustion chambers were unusual enough that people started calling them semi-Hemis. The production engine used a Holley 4-barrel carburetor flowing about 735 CFM, and Ford officially rated the street version at 375 horsepower. Torque was listed around 410 pound-feet in period specifications, but those numbers don't tell the whole story. Because this wasn't really a street engine wearing racing technology, it was a racing engine wearing street clothes. And Ford had a very specific reason for putting it into a Mustang: homologation. That word changed everything in 1960s racing. It was the bridge between showroom production and Sunday competition. The rulebook required manufacturers to build a minimum number of street cars equipped with the engine they wanted to race. No production cars meant no racing. It was that simple and that brutal. To race an engine in NASCAR, Ford needed to produce enough street versions to satisfy the rules. So Ford did something that sounds almost insane today. It took a giant NASCAR-oriented V8 and put it into a Mustang. Except there was one enormous problem. The Mustang wasn't built for it. The 429 was physically huge. Ford couldn't simply pull a smaller V8 out and drop the new engine into the same space. The engine bay had to be heavily modified. The suspension had to be reworked. The front structure had to accommodate the extra mass and dimensions. The shock towers needed reshaping. The inner fenders required extensive surgery. The front suspension geometry had to be completely reconsidered. And Kar Kraft, Ford's specialized engineering partner, became deeply involved in turning the idea into an actual production car. Kar Kraft wasn't just bolting parts together. They were essentially re-engineering the front half of every Boss 429 Mustang. Each car spent weeks in their Brighton, Michigan facility. Workers cut, welded, measured, and adjusted. They installed custom engine mounts. They fitted special headers designed to snake around the Mustang's tight chassis. They repositioned components that simply couldn't coexist with the massive engine. The result was a Mustang unlike almost anything Ford had built before. The battery moved to the trunk. The car received upgraded suspension components. A large rear anti-roll bar helped fight the handling problems created by the big engine. An oil cooler was fitted. The hood had to make room for the induction system. A functional hood scoop became mandatory, not decorative. The car sat on Magnum 500 wheels. Special front disc brakes helped slow the added mass. And every one of those modifications told the same story. This engine was not supposed to be there, but Ford needed it there, because somewhere else, on another kind of racetrack, this engine was supposed to be fighting Chevrolet and Chrysler. And then came the question that creates the mystery behind this entire story. If Ford had built such a monstrous engine for racing, why didn't they simply use it in Trans Am? The answer was sitting in the rulebook. The SCCA Trans Am series had created one of the most important restrictions in American road racing. The over 2-liter class had a maximum engine displacement of about 5.0 liters, or 305 cubic inches. That number shaped the entire muscle car racing war. It determined which engines could compete, which designs would succeed, which manufacturers could even enter the fight, and it created one of the most competitive racing series in American motorsports history. Chevrolet couldn't simply throw a 396 into a Camaro. Instead, engineers created the famous 302 by combining a 4.00-inch bore with a 3.00-inch stroke, producing about 302 cubic inches. Ford took a similar path. The Mustang's Trans Am weapon became the Boss 302, not the 429. The Boss 302 was engineered specifically around the rules, and that distinction is everything. Because the 429 wasn't rejected, because officials looked at it and said that engine is too powerful, it was rejected by mathematics. 429 cubic inches versus roughly 305. The difference was more than 40%. There was simply no legal way to run the stock displacement engine in that class. No protest hearing was needed. No technical inspection drama. No last-minute disqualification. The rulebook did the work before Ford ever showed up. So while Chevrolet was building high-revving small blocks for road courses, Ford was building a giant big block for NASCAR. 2 engines, 2 battlefields, 2 completely different philosophies. And yet both wore the Boss name. That's where things get interesting, because the Boss 429 wasn't just a giant engine. It was a piece of Ford's racing technology that eventually became far more important than its disappointing factory horsepower rating suggested. The street version's official 375 horsepower figure sounds almost ordinary today, but remember what Ford was trying to do. This was 1969. Insurance companies were watching. Regulators were asking questions. Safety advocates were gaining momentum. Manufacturers had learned to be conservative with official power ratings. The engine had a 4.36-inch bore, a forged crankshaft, forged pistons, aluminum cylinder heads, and enormous ports. The production heads used large valves with intake valve diameter around 2.28 inches and exhaust valves around 1.90 inches. Those valve sizes were enormous for the era. The ports flowed massive amounts of air. The combustion chamber design promoted efficient burning. This wasn't an economy car V8 with a bigger carburetor. It was a highly specialized breathing machine. And the reason for the huge bore was simple. Get more air in, burn more fuel, get the exhaust out faster, make more power. The enormous cylinder bore gave Ford room to install large valves without crowding them together. When valves are too close, airflow suffers, efficiency drops, power stalls. But with a 4.36-inch bore, Ford had space to optimize valve placement and maximize flow. The shorter 3.59-inch stroke also reduced piston travel compared with a long-stroke big block. That meant the engine could potentially live at higher RPM. Less piston travel meant less stress on connecting rods, less time accelerating and decelerating reciprocating mass, more potential for sustained high-speed operation. And that's exactly what Ford needed on the oval. High RPM, high speed, hour after hour, lap after lap. But on a road course, horsepower wasn't everything. The car had to turn, it had to brake, it had to change direction, and it had to do it again and again, corner after corner, braking zone after braking zone, acceleration phase, after acceleration phase. That was where the Boss 429 Mustang faced another problem: weight. The engine was massive, the iron block was heavy. Even with aluminum heads, the complete assembly tipped the scales significantly. The Mustang's front end became heavily loaded, weight distribution shifted forward, handling balance suffered. Turn-in response became sluggish. Ford had to move the battery to the trunk and add chassis and suspension changes just to make the car behave. And even with those changes, the Boss 429 was not the ideal Trans Am weapon. The Boss 302 was. That smaller engine allowed Ford to build the car around the rules instead of fighting against them. It was lighter, more compact, better balanced, more responsive, and Ford's decision proved correct. The 1970 season became one of the most important years in Trans Am history. Ford's Boss 302 powered Mustangs fought Chevrolet Camaros, AMC Javelins, and Chrysler's new Trans Am machines. The racing was brutal. Drivers pushed to the absolute limit. Parnelli Jones wheeled his Mustang with controlled aggression. George Follmer became a fierce competitor. Mark Donohue dominated in the Camaro. Every race was a war. These cars weren't stripped-down prototypes. They were based on production muscle cars, but the teams turned them into serious road racing weapons. The engines were pushed hard, the brakes were punished, tires were destroyed, pit crews became part of the competition. Strategy mattered as much as speed. Reliability became the difference between winning and watching, and Ford's Mustang program ultimately won the 1970 Manufacturers' Championship by a single point over AMC. 1 point after an entire season of racing. That's the part that makes the story so fascinating. The engine that looked like the ultimate weapon wasn't the engine that won Ford the Trans Am War. The smaller engine did. The big one had a different mission: NASCAR. And once you understand that, the Boss 429 starts to make sense. Ford wasn't building a giant engine because it wanted the fastest Mustang in every form of racing. It was building a homologation engine. The Mustang was essentially the paperwork Ford needed to make the racing engine legal. It was the production proof, the regulatory requirement, the minimum necessary to satisfy the rulebook. That's why the production numbers were so small. Ford built only around 1,359 Boss 429 Mustangs across 1969 and 1970, with roughly 860 in 1969 and 499 in 1970, depending on how individual production records are counted. Think about that. A normal Mustang was mass-produced, hundreds of thousands rolling off assembly lines, options for every buyer, colors for every taste. The Boss 429 was practically hand-finished, each one a special project, each one requiring extensive custom work. Ford shipped the cars to Kar Kraft in Brighton, Michigan, where the engine installation and associated modifications were completed. The process was slow, expensive, and complicated. You couldn't rush it, you couldn't automate it, you couldn't build them like regular Mustangs. The Boss 429 package itself added more than $1,200 to the Mustang's price in period. That was enormous money in 1969. A standard Mustang could be had for around $2,600. The Boss 429 package represented nearly half that amount. It priced the car out of reach for many buyers. Ford wasn't building thousands of these because thousands of customers demanded them. It was building them because racing demanded a production connection. And there was another irony. The Mustang Boss 429 wasn't even the car Ford intended to race in NASCAR. The engine was the star. The Mustang was the homologation host. The actual NASCAR applications were tied to Ford's larger stock car platforms, including the Torino Talladega and Mercury Cyclone programs. Those cars had the aerodynamics, the size, the weight distribution, the platform architecture that made sense on NASCAR's super speedways. So the Mustang was carrying an engine that was designed to fight on a completely different track. And that's why calling the engine banned from Trans Am is technically a little misleading. It wasn't a dramatic courtroom-style ban. Nobody had to shut down Ford's race shop. There was no last-second inspection where an official discovered the 429 and threw Ford out. No angry confrontations. No appeals process, no controversy. The engine simply didn't fit the rules. And sometimes, the most powerful form of a racing ban is a number printed on a technical regulation sheet. 5 liters, 305 cubic inches. That's the ceiling. And Ford's engine was 429. Game over. But here's the twist. That limitation actually helped create one of Ford's greatest road racing engines. Because Ford couldn't use the 429, it had to develop something different. The Boss 302 combined the compact dimensions of the 302 with advanced cylinder head technology derived from Ford's Cleveland program. It was lighter, smaller, higher revving, and much better suited to a road course. The engine became a weapon built around corners rather than straight-line acceleration. It could rev to 8,000 revolutions per minute in race trim. The Velvet Train could handle sustained high-speed operation. The compact size improved weight distribution. The lighter reciprocating mass allowed faster throttle response. That was the genius of Trans Am. You couldn't simply win by building the biggest engine. You had to build the smartest one. Chevrolet understood that. Ford understood it. Chrysler learned it. AMC eventually learned it too. The rules forced the manufacturers to innovate, to think beyond raw displacement, to optimize rather than simply maximize. And that is why a seemingly restrictive regulation helped create some of the most famous American racing engines ever built. Meanwhile, the 429 continued evolving in its own world. In NASCAR trim, the engine's potential was vastly greater than the street rating suggested. NHRA notes that the racing version was believed to produce around 550 horsepower, while the street version was deliberately configured at a much lower official rating. That gap tells you what Ford was really selling. Not maximum street performance, racing hardware, proven technology, engineering credibility. The production engine was detuned and fitted with street-friendly equipment because it had to survive as a road car. It needed to idle smoothly, pass emissions testing, run on pump gas, deliver reasonable fuel economy, start reliably in cold weather. The race engine was another animal entirely, built for sustained high-speed operation, fed race fuel, tuned for maximum output, rebuilt regularly, maintained by professional crew chiefs. And once racers got their hands on the architecture, they found even more potential. The engine eventually became important in drag racing. Mickey Thompson used versions in his Mustang funny cars. Other racers experimented with forced induction. Superchargers appeared. Turbochargers followed. Nitrous oxide systems added another dimension. The basic architecture proved capable of handling serious power, and the engine eventually became associated with some of the most serious Ford drag racing efforts of the era. So the engine that couldn't enter Trans Am wasn't exactly forgotten, it simply went somewhere else. And that may be the most important lesson in this entire story. Racing history isn't always about the engine that wins. Sometimes it's about the engine that isn't allowed to compete, because that engine forces engineers to build something else, something better suited to the task, something more refined, something that might not have existed without those restrictions. In 1969, Ford had two very different answers to the same question. How do you beat America's best racing cars? For NASCAR, Ford went big, 429 cubic inches, massive bore, aluminum heads, semi-Hemi combustion chambers. For Trans Am, Ford went small, 302, lightweight, high revving, corner focused. One engine chased horsepower on the oval, the other chased balance through the corners, and the strange part is that both became legends. The Boss 429 became one of the rarest and most valuable muscle Mustangs ever produced. Today, pristine examples command six-figure prices. Collectors hunt them obsessively. Historians document every detail. Enthusiasts preserve them carefully. The Boss 302 became a genuine Trans Am racing weapon. It won races. It claimed championships. It proved Ford's engineering prowess. And it earned respect from competitors. One represented raw engineering excess. The other represented disciplined engineering. And the rule that kept the big engine out of Trans Am helped define the difference. So the next time you see a Boss 429, don't just look at the hood scoop. Think about what that engine was actually built to do. It wasn't born for the Trans Am road course. It was born from Ford's fight against Chevrolet and Chrysler on NASCAR's high-speed ovals. Its 4.36-inch bore and 3.59-inch stroke were chosen for a reason. Its enormous aluminum heads were chosen for a reason. Its strange semi-Hemi combustion chambers were chosen for a reason. And the Mustang carrying it existed largely because racing rules demanded that Ford build street versions. That is the hidden story. The Boss 429 wasn't a failed Trans Am engine. It was something more interesting. It was an engine built for one war that became famous in another world. And the Trans Am rulebook didn't destroy its racing career. It simply told Ford where that engine could not fight. Ford answered by building a different weapon, and that smaller weapon went on to win the 1970 Trans Am Manufacturers' Championship by a single point. Sometimes the greatest racing engine isn't the biggest one you can build. It's the one that fits the rules, survives the punishment, and gets to the finish line first. If you enjoyed this deep dive into one of Ford's strangest racing stories, let me know what engine we should uncover next. Because American racing history is full of engines that were too powerful, too expensive, too complicated, or simply born for the wrong battlefield. And some of those stories are even crazier than this one.